unit testing. So we're going to talk about how to test our code to make sure things are correct. We've seen a little bit about this already, inadvertently, with the idea of a constructor, right? So we have our class. It has a constructor. That takes an int. And we wrote that code that said check x, passing the value, and go. Check val, whatever. And then assign it a value, right? Assign the parameter to the value passed in. And then check val would be the, or check y or whatever I call it. I guess in this case it'd be check y. Would throw an exception if there's a problem, right? So this is how Java deals with things. If something goes wrong, it throws an exception. And this check y method is handy. It's static. Anything the class can call it. Then we don't have that problem with overriding. We check the value. If it's less than 0, say, it'll throw an exception, causing the program to crash. Or we have to throw an if you say that the method throws. Typically, not always, this is going to throw an illegal argument exception. That's an unchecked exception. It'll cause the program to crash. That's not always the case, but that's a very common case. So that's the concept of checking to see if parameters are correct. So unit testing is just a somewhat formal way of creating tests. I'm not going to do the actual syntax here, so don't pay attention to the syntax. It's the concepts. So we would write something like this. So we're going to call it X test. That means it's probably going to be checking the class X. And we might say we have to mark it with what's an annotation. What's called an annotation. We'll talk about that when I do the code. Right, so I might have something like test constructor, and I'll just do new x5, new x1, new x7, new x0, that kind of thing, where these are all valid values. Now, I like to be methodical, so I wouldn't actually do it in this order. What I would do is I'd pass in 0, I'd pass in 1, I'd pass in 5, I'd pass in 7, because those are ordered. 0 is really important, as is 1. So 0 is important because it is testing the lowest valid value. 1 is testing one away from that. And instead of 7, what I'd probably use is think it's value. Right, the highest possible integer, and I do integer max value minus 1, which would be the second highest possible integer. And I just make sure, I'm not even assigning those anything, I'm just making sure that they don't throw an exception. I don't care about anything beyond that. They should all succeed. When I read the code, I can look at that and go, those should all succeed. Again, I'm not going to get into the details of how we write the code. You'll see it in the actual code portion. But we have a similar kind of thing when we pass in something like -1, which should throw an exception because we're saying that the value passed in has to be 0 or greater. So -1, we're going to do the same thing, but there's some additional code here that we do to make sure that we throw the appropriate exception. So you'll see that kind of thing. So what we want to do when we're writing our tests, and I'm not actually going to get you to write the tests as part of an assignment, but we'll get some practice writing some tests. what you want to do is you want to check all of the boundary cases, all the corner cases, all the special cases, right? So if I say it's got to be greater than 0, things I'm going to check are 0, 1, -1, -2, 2, 100, -100, the minimum, the smallest possible integer, the largest possible integer, right? And make sure that all those, that full range of things gets tested. I don't have to test literally every integer. I have to test the really important ones. 0, 1, -1 are super important. These are less so. These are just here for completeness, and then the min and max are just, again, there because they're extreme bounds. So again, those would be really important. So everything around where I say what I say is the valid range. 0 and higher is the valid range. Well, I want to try the biggest one. I want to try the smallest one. I want to try one away from the smallest one. I want to try one away from the biggest one. I want to try something in the middle. A reasonable subset. That's actually about it. There's not much to unit testing. The rest of it, again, I'll show you in code and I'll cover in code. Unit testing frameworks, there are a number of them. The most popular set of them comes from JUnit. So JUnit is not the oldest unit testing framework, but it is the one that gained a lot of traction early on. So there are C, C++ and C Sharp and Java and other ones that are based off of JUnit. JUnit as well has advanced over the years. We're now into JUnit 5. It's been adopting more and more of the Java language changes. So some things wouldn't be doable in other languages, but they all, if you know JUnit, it's not hard to pick up another framework in another language that's based off of it. They'll have a similar flavor. We also use, or I use, you will be using, another library called Hamcrest, and I'll show you why in the unit tests, but I find that it makes unit tests more readable. I dislike the way JUnit does some things, and this cleans that up. So that's it for unit testing. Unit testing is a really big, important subject. I've scratched the surface, but now you get the point of it, right? The point of it is to write some automated tests to make sure that my code does what I think it's supposed to do. It also forms basically the specification for the code. The idea is that I can do this thing called refactoring, which is changing the code. And as I change the code, I can verify that the code still works the way I intend because it still passes all the tests. One thing to be careful of, the tests are only as good as you wrote them to be. So if you write really bad tests, you'll be not doing a very good job of testing. Honestly, the simplest thing to keep in mind there is you want to test all those corner cases. I will cover more tidbits in the actual coding because they come up a lot more, but that's it, right? You're writing tests that you can run automatically to verify that any changes you've made to the code still work. That's it.
So here's the source code portion. We're going to start off with a redo of one thing. Going to set up the project structure to make sure we've got the libraries installed. So the one library we're going to need, and you get it from Maven, and we just type in org.hamcrest and hit the search. Takes a little bit. We can go for 2.2. That's the latest still. Yep. And we're also going to want these modules. So you see this source and it has sources get highlighted there. So there's two main directories we can create. And we can just come in here and say new folder, and we can say tests or test, and we can say Java. One thing here now. This is really important. A student didn't do this and it caused some trouble for a long time. Make sure that source doesn't get marked with anything. So Java gets marked as sources and test gets marked as tests. That's really important because when you're creating the unit tests, they'll automatically go in here and they're not part of the program we're going to deliver. When you're shipping a product to a user, you don't include all your tests. And then these are all our regular sources. So one other thing I'm going to do in here is going to make a new package. So a package is a directory structure in Java. It's just a way of organizing our classes. And the traditional thing is ca.bcit instead of bcit.ca. So we do what's called a reverse domain name. And then something unique, comp2526, unit testing. You'll have a similar thing for your assignment. So we can make a class. And let's see, what should we do for actually testing? Not a printer like a physical printer that'll print paper. We'll make an interface, but a thing that'll just print out a string. Don't have to mark interface methods as final. So it's an interface, which means any class that extends it or implements it is going to have to provide the implementation. And I just realized this is a horrible idea because it's really hard to test something that doesn't return a value. And I'm not going to call it printing then anymore. I'm going to call it a transformer. And the method will become transform. Right, so we're going to transform one string into a different string. That's testable. So the upper transformer is going to convert the string to all uppercase. I don't want it to turn null. I actually want it to just, we'll throw a new error. Not implemented yet. Just to remind us that we actually have to implement this. And we'll go ahead and make one other one. A null transformer, which I should do nothing. And we'll make these ones as final. So now we need to make the unit tests. What I'm going to do for that is right mouse click on the class name and say generate, and I want to generate a test. And I want to use JUnit5, and it can't find it, so it has to import it just like we did for Hamcrest. So doing this should let it do that. And we'll call the name upper transformer test, sure. Doesn't have a superclass, we want it in the same package. We'll put these in just so you can see them. We will remove them later on, but I'll show you what they do. So you'll see we have these imports and this import for assertions that we're not using yet. Before I go off and do the same thing for the null transformer, we'll just get this one up and running. So before each is an annotation, and annotations are things that tell the compiler to make your code do something special at runtime, basically. So the before each is actually saying, before I run this test, run this code. So it could be something like logging into a database or connecting to a server or deleting a file or creating a file to have a certain thing in it, whatever we need for this test to run. Teardown does the whatever we need to happen after this test is run. There's also it's not, they've changed the name, so I have to look that one up momentarily. Actually, I can look it up now. Just doing it on my phone. Okay, it's called before all. So there's an equivalent one called before all. That is going to be static. So this will run once before any tests run. And the before each runs for each test, right? So if we have 20 different tests, before each will happen before each of them, and before all will only happen before any of them run, right? But it only happen once. It's like a static block, static initializer, right? This is like an instance initializer. This is kind of like a constructor, but not really. So we don't need to use that. I rarely use them for tests with students, but they do come in handy sometimes, so you should be aware of them. So to get this to work, we're going to I always 100% make two things. Almost always. I don't need to this time. The reason I don't need to this time is well, actually, I still can. But the reason I don't do it for this one is the upper transformer has no state. That means it has no variables out here. Ideally, the classes we create don't have any variables. If they don't have variables, they have no state. There's nothing to what we call mutate. If we don't have mutation stuff, it makes our life so much better because it makes the code much easier to write, much harder to get wrong. State persists between function method calls. So if we screw things up, and a lot of students do manage to screw things up by providing state when they don't need it, that makes our life much harder to deal with. So not having state is better. We will talk more about state as we go through the course. For now, we don't need to test things with more than one thing right now because we have no state, so we're good. So we're going to assert and it's being difficult for me. Some days, life is just hard. There we go. So for me, it's options. So you might be alt return to bring this up. But worst case, you have to type in this this particular import by hand if you can't figure out how to make it happen. So we're going to assert that when we call the transformer dot transform hello, it's just equal to, again, option or alt for you. And we want the matchers one, or we can do core matchers, doesn't really matter. Any of these will do. They have multiple ones. And again, if you can't figure out how to get that to happen, you just have to type in the importing. So here's why I like Hamcrest better. It's easier to read. If I wasn't using Hamcrest, it would be something along the lines of this. I find this unreadable, right? So I'm going to assert that hello is equal to whatever this method returns. I much prefer to say assert that this method call equals to that, right? It just reads more naturally to me. So that's why I use Hamcrest. So when we call the transformer transform using an upper transformer on the string hello, it's going to give us all uppercase hello because it's converting to uppercase. If we give it all uppercase hello, it'll do that. If we get a hello like that, it'll do that. If we do nothing, it'll do nothing. If we give it x, y, z, x, y, 2, it'll give us x, y, 2. And if we give it a, it'll give us a. And if we give it a question mark, it'll give us a question mark. And if we do question mark ABC, it'll give us ABC. Right? So some number of tests to see various different things, all lowercase, all uppercase, a mix of it, an empty string, string with one character, something that can't be converted to uppercase, something that's a mix of it. You know, I guess there's another one we didn't do. What happens if you do ABC with a question mark at the end? Right, so I'm trying to think of all the things that, you know, all the variations I can think of. I'm not going to worry about errors at the moment. I'm just going to go with the working things. So let's give this a try. Let's just run it and see what happens. The annotation in this case, all these at tests, tells it when you run the tests, it takes this method here and treats it as a unit test because it's marked with that test. If I don't mark it with that test, it doesn't run as a unit test. So you'll see a bunch of methods with that test, but sometimes I'll give you methods that are utility methods and they're just there to help the tests out. They don't actually run as tests. So, sorry, let's run that again just so we can see what happened. And it's going to tell us that it failed, right? So one test failed, 0 passed. The error, we got an error not implemented, and it's happening when we call this. Right? So it's pretty simple. We just go to upper transform, and how are we going to deal with this? Very simply, we're going to return stir.to uppercase. I will never actually write code like that. I will do this. Why? Because after this method returns, I can put my mouse over it and I can actually see the value of it if I'm using the debugger. So it makes my life so much easier to find mistakes. Otherwise, I'd have to jump through some hoops to do that. So I never return an expression. I only return a variable. Even if it could have been a one-line bit of code, I do 3. Just works better for me. Nope, don't want that. And now they're all passing. Yay, it was that simple. Unfortunately, there's one thing I've forgotten. What happens? I need to think of the error cases, right? So what happens if, what can go wrong, right? So what are all possible things that can go wrong? Well, the only thing I haven't dealt with is if stir equals null. So how do I want to deal with stir equaling null? So I generally make another method for this. And I'll title it bad transform. It doesn't have to match the method. It's just convention that we make it match, right? This method is called transform. We're calling the transform method because we're testing the transform. Well, here we're testing a bad transform. And I need to look something up really quick. Let's probably have it. You can see I did this similar thing for a assignment before. It will not be your assignment this time. That's good. I'm looking for. Some of this code will not be very understandable to you, and we will come to it later. But it will explain the code. Okay. So what on earth does this do? And this little thing here we'll cover later on in the course. This is what we call a closure. Do not worry about it right now. It's a fancy way of making a function call or a method call. So please completely ignore it. It's required for this bit of code. We will, can't ignore it. It's right there, but we will cover it later on in the course in a couple of weeks. So what we're saying here is assert throws. So this makes sure that when we call this method, it's supposed to throw an exception. Specifically, it's supposed to throw an illegal argument exception. We're going to assign that to a throwable. We're allowed to do that because a legal argument exception is a kind of throwable. And then what we're going to do is we're going to get the message from the exception and make sure that it equals to the stir cannot be null. Same kind of thing that we did up here. It's just a regular unit test at that point in time. So this does some fancy stuff underneath to make sure that this throws an exception and that exception is an illegal argument exception. So let's go ahead and run this, and it will not work. It's going to say that it's an unexpected type. It expected an illegal argument exception, but it got a null pointer exception. So that's right here. So in an ideal world, what we will have done is we will have gone off and written all these tests and thought up all the bad things that can go wrong. Here's all the bad things that can go wrong. Here's all the good things and how it's supposed to work in that case. And when we're done that, then we actually start implementing our code. This is exactly what I'm going to give you in terms of an assignment. So you will get a bunch of unit tests and you'll have to pass them. You're not allowed to change the unit tests. That's not acceptable. So here we coded, we saw this, we coded it, we made our test, we made all these test passes, and now it's failing this test. And it just means that we have to come in here and say if stir equals null, throw new argument exception, stir cannot be null. How do I know that the message has to be stir cannot be null? Very simply, the unit tests tell me stir cannot be null. Literally right there. So if I run this now, there we go, passes. I can also come in here and just say run all tests. And they're all passing. So what would happen next is I would do the same kind of thing. I'm going to copy this, going to paste it, going to rename it to the Null Transformer test. And a Null Transformer test is quite simple. It doesn't make any changes. And this now becomes a Null Transformer. Now, Null Transformer actually doesn't even have to have this particular thing. Null is perfectly fine. So we're actually going to change the test here. So let's say that this is the assignment we got, and we have, so it came with all of the unit tests, and now we need to pass them. So we generally just code the simplest thing that'll work. Well, it looks like we're not supposed to do anything to the argument, so we'll just return it, and we'll see if that works. And it does. No problem. Okay. I can write something if, I could be silly, if stir equals null. I've seen students write code like this. Return null, else return stir. That's exactly what some students would write, okay? Actually, not even students, professional programmers. Two things. Once you return, we don't need the else, so you can get rid of the else. It's not needed. Oh, but sorry, before I do that, let's make sure that the tests all pass. Yes, they do. So I don't need the else. I can have that. I've made a change. I'm going to test them, make sure it all works. It does. It's telling me here that this can be simplified. But I'm not going to simplify it. I'm going to do something else first. I only like to have one return in my function. Right? I'm sure I've gone through this before, but I'm going to go through it again. It's a worthwhile lesson. So run the test again. Right, so now I only have one return. I'm happy. This is the way you go about doing that. But you notice it's unhappy here. It's telling me I don't need to do something. I'm doing something more complex than I need to. So let's see how it fixes it. Okay, there we go. So we can just run that. This is refactoring, what I referred to in the first part. And once we realize that, hey, we're just assigning the value straight up, there's nothing changes, we can just return stir like we had to begin with. Run the tests. All pass. Right, so I can keep making changes to my code and make sure it passes. Right? Your assignment, or your not assignment, your task, your homework, is quite simply to make two new transformers. A lowercase transformer that works just like uppercase, but it makes sure that everything goes to lowercase, so all over hello, all over hello, all over hello. And then write any other transformer you wish. Maybe a transformer that takes question marks and turns them into exclamation marks, or a transformer that removes anything that isn't a number. You make up a transformer and write your own tests and pass them. So that would be my homework for you, my challenge for you to try. Okay? And we can we'll take a look at those next day.